And lastly, we have station 4. So we've got a lamp and our globe. And it says, hold the globe upright with the North Pole facing directly upward and the South Pole facing downward. So I've got that. Hold the globe so the light is perpendicular to the globe. There, to the equator. Shining directly on the equator. Observe how the light is distributed across the globe. So, let's see. I need to adjust where my phone is. So, basically, what you should notice is that we're getting the most intense sun at the equator. And then it diffuses as it goes to the poles. So which regions have the most light and the least light? The regions closest to the equator receive the most light and the least light at the poles. Now it says to tilt the earth slightly. Tilting. This is the best angle, but you know, doing this by myself. So, all right, tilting the earth slightly. Move the globe in a circle around the light. This represents the orbit of the earth around the sun. Observe how the light is distributed across the globe at different points of the globe's rotation. Note that the amount of sunlight received at the equator, the pole, the Tropic of Capricorn, and Cancer, and consider how much the amount of solar energy received would affect each region's climate. How does June in the northern hemisphere compare to June in the southern hemisphere? So if we pretend this is June, and the northern hemisphere is tilted toward the sun, and so that is our summer. So in the southern hemisphere, it's tilted away. So they are actually having their winter when we're having our summer. And then when the earth goes around, now let's pretend this over here is, you see it? No. We'll go exact opposite side. And so for us, it's winter, we're tilted away. And for the southern hemisphere, it's summer because they are now tilted toward the sun. How does the amount of sunlight an area receives influence the climate? When the sun is concentrated over a smaller surface area, like when it's at the equator, there's going to be warmer temperatures. Also, the angle of radiation is smaller, so the energy is spread. When the angle is smaller, the spread is over a larger area, and that's going to result in warmer temperatures.